Hi guys, so this is going to be more tutorial video where we try to do something useful with this particle photon development board. I had already created unboxing and review video, and I promise we're gonna do some interesting project. And today we will try to make temperature sensor which will sense the temperature and send it to the cloud. So what do we need? First of all, we need our particle photon development board. We need breadboard. In this particular case, we need 20K resistor. I have a bunch of them. We need a bunch of little connectors like this, and obviously we need the temperature sensor itself. So this is temperature sensor I made myself. Inside there is a thermistor, 100 kilo ohm. 100 kilo ohm Semitech 104 GTA2, which is actually this thermistor was made for my 3D printer, so I can screw it into my hot end, and it will monitor temperature. So it's fairly precise thermistor with pretty big temperature ranges. It's operational till 300 degrees Celsius, which is perfect for 3D printer. So this can be used for high temperature applications. So also I can include the link how can you do it yourself. So I'll tell you briefly. This is bronze or brass standoff. I think it's brass standoff. And inside there is a thermistor. And also I use muffler cement in order to cement thermistor in place. And those white leads are Teflon leads, to make sure that they are not gonna, burn or anything like that, and short circuit those wires not gonna burn, essentially. I'm not sure what kind of temperature this heat shrink will withstand, but hey, this is Teflon wires. This is Teflon tubing. There is a high temperature solder there, and some heat shrink here. And I use regular connector over here. I'm not gonna, this is how I connect it to the 3D printer, so we're gonna just reuse this connection. All right, so let's build our project. So first of all, I want to say that I'm using only 3 pins, 3 outputs at this particle photon board. So I'll be using 3.3 volt. Ground over here and A4, and I only soldered those necessary pins, the pins I'll be using. In case I would like to actually unsolder those headers and use some different configuration of headers to have it more compact. Alright, so let's start building it. So first of all, I have to connect this jumper wire with 3.3 volt. Then I use my resistor, connect it over here, place it over here, make sure it has good connection. Then connect this resistor with A4. Okay, that's going to be one resistor or one part of our voltage divider. Then connect this wire to the ground, and use white one to connect to another. This is like a middle point of voltage divider, and another resistor voltage divider would be our thermistor, which will have variable resistance, depends on the temperature, and because of the variable resistance, the voltage over here at this middle point will be changing accordingly. Okay, well, so we have it built. That was pretty easy, right? All right, so over here we do have our program, which is extremely simple. As you can see, there are several constants we have to remember. So we do have constants which are 20,000 is our resistance of the constant resistor. Beta is necessary coefficient which you can figure out for your specific thermistor, and this is in Kelvin. So then thermistor resistance at normal temperature of 25 Celsius, and 25 Celsius is normal room temperature as well as a constant. So then we do call in a loop, we call this thermistor function, which actually gonna do analog read at pin 4 and then pass it the value into the function itself, which does the whole calculation based on the value. So value is actually voltage reading, and then we have to calculate the resistance based on this, and then based on that we have this the function which actually uses beta in order to figure out the temperature. And then we do spark publish, which is gonna essentially publish the temperature value at the spark particle dashboard. So let's try to connect our assembled contraption over here and upload our new program into it. Connected. So let's wait till it actually starts blinking cyan again. That means it's connected to the cloud. My God, I hate this word cloud. And if we go here back to our web UI, we can select currently connected device. In this case is my core 1. Sorry, wrong. My core is not connected. So looks like this UI didn't clue in. Let's reload it or something. Okay, so my Photon 1 is connected. We select it as default device and we're gonna flash it. At this time you can see the board flashing magenta or pink, then green, and then start flashing blue. So now we can switch to dashboard and go to logs, and we will see temperature readings measured every second. So now if you want to verify that we are somewhat correct, we can do something like this. Grab the thermistor and hold it in our hand for a minute or so, and you can see the temperature increasing, which, you know, which is about right, so 27 Celsius, and it's rising. It's slowly going up. Okay, so we started at almost 24 degrees, right? How else we verify that we have correct temperature? So if you're a happy owner of this contraption, so you can measure ambient temperature as well. So this is Sensor Tech 2 from TI, and it can measure temperature. So let's start our application, which connects to the sensor, and it will show temperature. And we see that the ambient temperature is 24.3 Celsius, which is exactly what we got, plus minus. So I think we are pretty good here. So in general, it was very simple to make particle photon board working and measuring temperature from the thermistor and publishing stuff on online. So here we have our prototype. It's perfectly working in logging temperature online. Pretty much everything what we need. But if you want to use it actually for real life temperature application to measure stuff, you probably want to have it not on breadboard and battery powered. So I already created my more compact version. I'll show it to you right now. Okay, let's disconnect this. All right, here we are. We do have a battery, and we have my second already modernized photon board. So what I've done here, I soldered a row of angled headers to save vertical space, and I'm using V in and ground to provide power from the battery, using A4, and A4 connected to 3.3 volt via 20 kilo ohm resistor, using single header over here to connect thermistor to the ground, and thermistor also connected with another pin to the A4, which our analog ADC readings pin. So yeah, I'm planning to reuse this thermistor for its original purpose for 3D printer. That's why I didn't change the header or solder it or anything like that. But if you connect the battery, excuse me, battery, it works. This is a one cell LiPo battery. This is 750 milliamp. Pretty small battery. Actually, I like it a lot. I'm using it for, I have several of those and using them for all sorts of small projects. It works very well. Also, I 3D printed the very simple case for it. This is just a rectangular kind of pocket, and I'm planning to insert everything in this pocket just like that. It will make it more compact, and I can, connect this thermistor to anything I want and measure the temperature in real time. This is probably one of the simplest projects you can do with your particle photon. Particle core will work instead of photon exactly the same way. They are completely pin compatible. I already tried that too. And also, here's my suggested way of packaging it with battery. I mean, you can do it any other way. I think this is as easy as you can get, or as easy as you can do it. If you're planning to use different thermistor, you can totally do it, but you would have to go and read your datasheets for that particular thermistor and figure out the nominal resistance at room temperature and also beta value, and just plug them into the program, recompile, re-upload, and it should work. Make sure you would test your temperature with some other thermometer or thermosensing devices, just to make sure that your readings are somewhat okay. Well, if you like this short tutorial, please like, and if you like all my other videos, please subscribe. Thank you for watching.